welcome to Chem Show. Today we are discussing the structure of phenolphthalein. It is phenolphthalein from plus 2 onwards we are using in the laboratory, isn't it? It is phenolphthalein, as we already know that it is a universal indicator. Okay, it's an indicator in acid-base titration. It is regarded as a, or it serves as a universal indicator. Okay, is phenolphthalein, the structure of phenolphthalein. Phenolphthalein is prepared when phenol is treated with phthalic anhydride. Phenol is treated with phthalic anhydride. Phenol in the ratio 2:1. This is when phenol is treated with phthalic anhydride in the ratio 2:1. With the presence of concentrated H2SO4. Heated. Elimination of water molecule takes place. Okay. Elimination of water molecule, that is hydrogen from here and hydrogen from here. H2O molecule is eliminated and we are getting this structure, that is phenolphthalein, that is structure of phenolphthalein. Okay, this phenolphthalein is colorless. Okay, this phenolphthalein this is the structure of phenolphthalein, that is prepared by heating phthalic anhydride, by heating phenol with phthalic anhydride in the molar ratio 2:1 in presence of concentrated H2SO4. The elimination of water molecule results in the formation of phenolphthalein. That is the structure of phenolphthalein. Okay, it is phenolphthalein is used as an indicator in acid-base titration and this serves as a universal indicator. Okay, now let us discuss the explanation of the pH-related color change of phenolphthalein. As we all know that since it is an indicator, that is, it shows some color change during pH changes. That is, phenolphthalein changes its color when pH changes. That is, phenolphthalein changes color when pH changes. Okay. Since phenolphthalein is a weak acid, it is used as an acid-base indicator because it's acidic, that is benzenoid form, and in base it is quinonoid form, that is it is having two different form in acidic and basic solution. That is, its acidic form is benzenoid form and its basic form is quinonoid form, and these two forms have different absorption spectra. These two, benzenoid and quinonoid form, have different absorption spectra and they show pH related color changes. Okay, when pH changes they show different color. Normally phenolphthalein is colorless. Okay, normally phenolphthalein is colorless. It's benzenoid form. It's benzenoid form. Just colorless. Okay. That is below pH 8. pH 8, that is below 7, is acidic in nature. Is below pH 8, it exists in colorless benzenoid form. That is, in acidic, it is in colorless form. It is benzenoid form. It is due to the benzenoid form. Colorless nature is due to the benzenoid form. After that, quinoid form. We are getting this quinoid form. After this conversion, we are getting this quinoid form, which is red in color. Which is the quinoid form of phenolphthalein, which is red in color. This is due to red quinoid form that is above pH 9.5. That is above 7, it is basic in nature. That is, in basic medium, it is red in color. Phenolphthalein show red color due to quinoid form. But in acidic, that is below 7. This, actually, normally it is below 7 is the actual pH range of acidic condition. That is 0 to 7. Below 7 is acidic. But here, it is below pH 8 itself, it is showing colorless. Okay. It show benzenoid, that is due to benzenoid form. It show colorless. Okay. And red color in the basic medium is due to quinoid form. Since phenolphthalein is a weak acid which is used as an acid-base indicator because it's acidic benzenoid form. Acidic benzenoid form and basic quinoid form have different absorption spectra, and they both have different absorption spectra, and they show pH related color changes. This phenolphthalein changes color in the pH range 8 to 9.5. 8 to 9.5, they show color change. They show color change between 8 to 9.5. That is, below pH 8, it exists in colorless, that is benzenoid form, and above 9.5, it exists in a red quinoid form. Okay. Another interesting factor about phenolphthalein is when it is treated with alkali. It first turns red color, and but on addition of excess amount of this alkali, that is NaOH, it turns colorless again. Again it is turning colorless. That is, first phenolphthalein, when it is treated with alkali, that is NaOH, it first turns red in color. After that, if we are adding excess amount of NaOH, it turns colorless. Okay. It is on addition with NaOH, elimination of H2O, and forming this product, which is benzenoid, which is colorless. On rearrangement, this electron shift here, and this electron shift here. We are getting this product, that is double bond O, and this bond breaks and we are getting here ONA. This Na will attack here. Okay, O minus Na plus. Now next, by the addition of excess amount of NaOH, again elimination of H2O molecule, and we are getting another product. Here I am writing here. This double bond, this benzenite form COO minus Na. Okay, which is quinonoid structure, that is red colored structure. This quinonoid structure, that is red colored structure. Red colored. After that, on treatment with alkali, that is excess of alkali, what is happening? This OH minus will attack here, nucleophile will come and attack here. This Na plus retain its position there, getting the structure as the same as before. We are getting the structure like this. So minus Na plus which is trisodium. That is, sodium is 3 times substituted. That is trisodium salt. This quinonoid structure is destroyed while we are adding excess amount of NaOH. Okay, if we are adding excess amount of NaOH, this quinonoid structure destroyed, and we are getting this structure. This is having colorless. That is, this is having colorless. This is colorless due to the trisodium salt. Formation of trisodium salt due to the addition of excess amount of NaOH will result the colorless solution. That is due to the trisodium salt. That is, first when alkali is added, what we are getting is a benzenite structure which is colorless. Okay, and this structure changes to this structure, that is quinonoid form, which is quinonoid form. Which is red in color. Okay, this structure is red in color, which is quinonoid form. Quinonoid form is red in color, and after that addition of excess amount of NaOH, it is converted into this structure, this type of structure, and which is also quinonoid form. Okay, and after that, if you are adding excess amount of NaOH, that is sodium get tri-substituted and forming trisodium salt, and which is colorless. Okay, Hence, we can conclude that when we treat it with alkali, phenolphthalein undergoes an interesting color change. That is, it turns red first, but on addition of excess amount of alkali, it turns colorless again. Okay. Hope you all got the point. So, if you have any doubts regarding this section, that is pH related doubts or anything else, you can ask the doubts in the comment box. Okay. And finally, thank you.